Hello everyone. Today our topic is exploring graphical features of MATLAB and Mathematica software. So with the help of some examples, we will learn how to draw 2D and 3D plots. Okay, so this one is Mathematica environment and this one is MATLAB. Okay, so we can write here, it's a unlike MATLAB, this one here in Mathematica, we are having so many options. So we can use it as a word editor also. So here we can see here. So we can write here like plain text, then coding also we can write here, and other we can write here title. So let's write here exploring uh, graphical features of MATLAB and Mathematica. Okay, so after writing this one, we have to we can press the down key, and then it is ready for the command here. And here the command line here we generally see that it's double arrow. It shows that this is the command prompt in the command window, and we can write the coding here. Let's start with a very simple function. uh, Plot sine, then sine x, sine of x into sine of 2 into x. Okay, we can take two functions rather. We can take two functions, sine x and sine 2x, and we can compare sine x and sine 2x. We are taking two functions, and x ranges from 0 to 2 pi. 2 pi. So this is the graph we are getting for this simple functions. The one is sine 2x, and the other one is sine x, and the other one is sine 2x. Okay, so now we will solve one problem here. Plot the function yx is equal to e to the power minus x into sine 12x. So let's do it in Mathematica. Okay, so let's take here, let's write here uh, y here plot, and then exp exponential function, and then we can write here minus of x into sine of 12x, 12 into x. So this is the function, and then we will write here x will lie from 0 to suppose 3 pi, 3 into pi. Okay, so plot exponential minus x sine 12 into x, comma, so let's run it. Okay, so this is the graph we are getting, uh, and now let's take one more problem here from the 2D plot. So here we are having y is equal to sine x, then y1 is equal to x, and here again x minus x cube by 6. So actually it is Taylor series expansion of sine x. So here we are taking one term, and here we are taking 2 term, and this is the actual function. So we have to draw the same all three plots on the same graph. So let's start here. We will do this on the MATLAB also on this one. So let's start here with this one. So plot in Mathematica. So here we can write plot, and then three functions are there. So curly bracket sine of uh, here we are having x, then second one is x, then third one is we are having x minus x x x cube divided by 3 divided by 6. So Taylor series expansion here divided by 6, and then uh, after this one we have to we will close this curly bracket, then comma, then we will write the value of x will lie from 0 to 0 to suppose 0 to 2 pi, 0 to 2 into pi. So this is we are having, okay. So this is plot sine x. So there are three plots, sine x here, then x minus x cube by 6, and x varies from 0 to 2 pi. Okay, so let's draw this graph. So this is the graph we are getting here, all three graphs. So we can and then one more thing we can do here. We can change the color of the three plots. So we can write plot style, and then here we are having plot style, and then we can write here plot style, and R, and here we can write red, and then RGB, green, let's write green, and then blue, three color. Okay, so now let's run it and see. Okay, so the first graph is sine x is red. So this is the actual graph. This is the first approximation, green one, first approximation. This is the second approximation. Okay, the same thing we can do here in MATLAB. In MATLAB also we can do the same thing, and for this one what we have to do, first thing, with x is equal to, we have to line space, we have to make a vector here. So from 0 to 2 pi here, all we can see that this pi is small, start with a small, so 2 pi, and we can divide it into 100 parts. Okay, then we don't want the result here, so we immediately, so we have to separate it with semicolon. So here we are writing this way. Okay, so here, yeah, so it's actually line space. Okay, and then we can plot here a small it's a plot of so plot of here three functions are there, so all we want to draw simultaneously. So for this one we can write here x comma sine of x, then the second function, and then it is of red color, so we will write here red R, and then the second one is x comma x. So x and then here it is green, so G. Then the third one is x and graph between f and x, x minus x cube, x cube by 3 by 6. So this is we are having, this is we will put here dot because it's a vector operation we have to do here, so that's why. And x cube by 3, and this is divided by 6. Okay, so divided by 6, and then this one is, suppose we want this one as blue color, so D. Blue color. So we have done x cube. So this is the graph we are having here. So you can see that this is the sinusoidal graph. This is the first approximation, green color, and this is the third one, like with two approximation, like taking only two terms. Okay, so now let's take some 3D problems, 3D plotting. So for 3D plotting we have to, let's here suppose we can write here plot, then 3D, plot 3D, and then suppose we are having function of sine of x into sine of x into sine of 2y, 2 into y, 2 into y, and we want to draw the plot of this sine x into sine 2y, and x varies from here, and x varies from minus of 2 into pi, 2 into pi, to 2 into pi, and this one similarly y varies here, y varies from, we can write the same thing for y here, we can write here y. So okay, so now let's check. So this is the graph we are getting here. Okay, so this is the graph we are getting here. Okay, so we can, there are meshes also, so we can write here mesh, and then we can write here, then again we can, so without mesh we are having. So let's take one problem here again, and draw the plot of the function z is equal to sin x into sin y e to the power minus x square y plus y square upon 4. Okay, so this kind of 3D plotting we will do in MATLAB, as well as in Mathematica. So let's do it in Mathematica. So our function, first thing plot, and then 3D, plot 3D, then we will write here it's a exponential function, so exp, and then doing this one plot, 3D plot. So first thing we will write is plot 3D, and then sine of x, sine of x into sine of y, sine of y, then exponential exp, exponential, and then minus of, we can exponential, we can special character we can take here, and then we can write here x, x square plus y square. This one we can put in bracket, and then divided by 4, bracket close, on x minus 5, 5. Again we can copy and write the same thing here, y, okay, bracket close. So it's a sine x, sine y, exponential of minus x square plus y square by 4, and then x varies from minus 5 to plus 5, and y also from minus 5 to plus 5. So let's run it. So this is the graph we are getting. In MATLAB. So first thing we have to do is we have to make an array. So from minus 5 to vector from minus 5 to 5. So let's take the point interval as 5.2, and it is from minus 5 to plus 5. So we are having, then we can make a grid of x and y points in the xy plane with mesh grid, and say u, comma u, okay, and then we will write the function z is equal to sine of capital X into dot we are giving because it's an array, so sine of capital Y into star exponential, and then here we are giving minus of sqrt square root, and then x square, x dot square plus capital X. So we will write here capital X plus x square plus y square, and then so divided by 4, and then bracket we will close here, and then semicolon, and then here we will write surf x z. Okay. So okay, so this is the graph we are getting here for this one and this one. This is from MATLAB, this is from MATLAB, and this is from Mathematica. Okay, so we can see that both the graphs are similar. It depends on how many points we take. Okay, so this is what we have done: 2D plot, then we have done 3D plot,